Alright, this is Brendan and Jonathan. We did Ohm's law, and it's I over VR, and I is equal to the current divided by the voltage over resistance.
Alright, one of the variables is I, and I is equal to the current, and it's not C because C is already another variable in the circuits, and it's measured in amps or amperes. And what the current is it's like a flow of electricity in the circuit. And so the current is just flowing through the entire circuit, so a cord or a wire. And so that's how you measure it. And
Alright, the next variable is V, and it stands for voltage. And it's measured in volts, and you can find it on your batteries. Just our batteries we were using were 1.5 volts. Another example would be if you're going from like 2 points. You got point A and point B, the lower place, and then you got water up inside of them. Okay, your water, and then let's say you make a pipe between them. Your voltage is the potential for the water to flow from point A all the way down to point B. And so your volts is the absolute value between the difference in the positive and negative. So it's your potential to flow between the 2 points.
alright, so the next variable is R, and R equals the resistance in the circuit. And it's measured in ohms, and this is the sign. It's an omega sign from the Greek symbol. And what the resistance is kind of the opposition to the flow of electricity. And we can see it in an example. You have a given circuit, and the flow of electricity is going through, or the current. The resistance is resisting the flow. So by these resisting right here, this is going to be the resistance. And it's just going to limit the flow. It's just going to flow inside of here. And it's going to like reduce the flow of electricity. And yeah. Alright, this is the pyramid diagram, and it's commonly used in the circuits. And it is V is on the top, and that's for the voltage. And then in the left, it's going to be I for the current. And then the right, it's going to be R for the resistance. And what this is just kind of a tool to help you use the equations to help figure out the resistance, the current, or the voltage. And so you can have like relationships like R is equal to I V over I, and you can see that R is equal to V over I, and then you can have V equals R times I.
So you look, you see that this is the division sign and this is the multiplication. So if you cover it up, try to find V, cover it up, V equals R times I. I'm trying to find R, cover up R, and that equals velocity, or V over I, voltage over current.
And you have I equals V over R, and it's just the same thing.
I equals V over R.
And you can use these equations to find any of the variables that you might be missing. So if you have the voltage and you have the current, you can find the resistance.
So you need two variables to find the missing one. Alright, so this was our first thing we had to use, was our micrometer, and it's up there in our diagram. Okay. So the first thing we had to do was check the volts in each of our batteries. They're supposed to be 1.5 each, but we went ahead and check them, so we used each end and attached it. And right now it's reading like 1.2 volts instead of 1.5. So we had to factor that into our equations when we were finding it out. And next we had to find the resistance of our resistor, which is right there. And then to find that, we found out our battery's resistance without it. So battery only is 1.5 volts. And we found our current to be 9.27 and our resistance to be 1.618 ohms, and that's amps right here. And then over here, with battery with resistor, we had 1.5 volts, and then our amps was less because we had resistance in it, so it was 0.00046. And then this was our ohms, so we divided these two and subtracted it, and found our resistance to be 3.2, so about 3.2 resistance for our resistor. And then after we found that out, we attached our resistor to our batteries and slowly added batteries. Okay. And so we measured the current flowing through each battery and slowly added batteries until we had 10. And we measured it as we went up. Let me show you that in a bit. And so that's our diagram up here, is how we did it with our alligator clips attached to our micrometer. And we had 10 batteries total for our 10 data points, and we measured it as it went up. Alright. So this is our chart of everything we did. We had batteries and we went all the way up to 10 for the rule of 10. 1, 2, 3, 4, 5, 6, all the way to 10. And then we had voltage, resistance, and current. Our voltage is measured in volts, resistance measured in ohms, and our current is measured in milliamps. And so our voltage is our independent variable because that's what we're changing. It's supposed to go up by 1.5 with each battery, but they weren't always fully charged, so we tested them each, and this is what we got for each one as we went up. Our resistance was supposed to be a constant at about like 3.12, but it changed a little bit because as we added batteries, it had farther distance to travel, and there's a little bit more resistance as it went in. And our current was our dependent variable.
And the current depends on the resistance with the voltage, so that was why I was dependent on both of them. And this also, the resistance went down percentage-wise because as more voltage went through on the current, more current was allowed to go through the resistance, and the resistance almost would bust without it. And this is our chart for the numbers that we got. Alright, this is our graph that we got, and we did current over the voltage, and here's the slope of the graph. We did the line of best fit for the data, and it is the mathematical model or relationship for it is going to be y equals mx plus b, or ax plus b, and we got for the variables in the place, it's I equals 3.3438 milliamps over the volts, and then it's times the voltage for the slope, and then the line of best fit would be 0, so we wouldn't have a B.
And then they're directly proportional, so the current is directly proportional to the voltage.